Alrighty, I'm gonna go over the rate in, rate out FRQ. One important note about this particular FRQ was that your time intervals were really different. So you guys really had to pay attention to that in terms of when we were adding coal and when the coal was burning. So for part A, it asks you to find the total amount of coal in pounds added by the worker. This did not mean the total amount of coal at t is equal to 5. It only wanted the amount of coal added by the worker, so just the rate n part. So my rate n part is going to be the amount of coal being added, which is S of t. However, this starts at time t is equal to 2 hours and stops at t is equal to 5 hours. So I'm going to go from 2 to 5 of S of t dt. Now, if you put that into your handy-dandy calculator here, which I already have on my calculator, that is going to be my y2. So I'm going to say y2 with the integral from 2 to 4 of y2. That's going to give me, not 2 to 4, 2 to 5. Oops. 2 to 5. That's going to give me 27.896 pounds. So that's going to be my answer there. So 27.896 pounds. Part B is the amount of coal in the furnace increasing or decreasing at time t is equal to 4. So we have my rate n, which is S of t, and we have my rate out, which is B of t. Notice how my rate out, I'm starting at time t is equal to 0. It's burning at time t is equal to 0. So that's my B of t right there. And remember that because S of t and B of t are already rates, aka they're already derivatives, what I can do now is just plug in 4 into S of t and B of t and see what that value is. So doing that on the calculator, my rate n is going to be S of t, which is y of 2. So I'm going to say y of 2 minus y of 1, which represents my rate out. And then I'm going to evaluate that at 4. Now, if I evaluate that at 4, I'm going to get 1.9863. Oops, that should be B of 4. It's equal to 1.8963, which is greater than 0. And once you to justify your answer, so you're going to say that the amounts of coal in the furnace is increasing at time t is equal to 4 because S of 4 minus B of 4 is greater than 0. All right, part C is going to be the tricky part because, once again, you had to look at your time intervals. From 0 to 5, at what time will the amount of coal be a maximum? So here's what we know so far based off of my question. I have my rate n, but that only starts at 2 to 5. So I'm going to go from, let's see, 2 to t, and that's going to be S of t dt. And then I also have my rate out. I'm burning, once again, at time t is equal to 0. So I'm going to have from 0 to t, B of t dt. But then also, don't forget that at time t is equal to 0, there are 500 pounds of coal in the furnace. So I also need to include that in my little equation right here. So I have 500 plus the integral from 2 to t of S of t dt minus the integral from 0 to t B of t dt. That's going to be my equation. Now, to find out when the amount of coal will be a maximum, I'm going to go ahead and take the derivative of that. and find my critical point. So A prime of t using FTC part 2. Oops, let me change this. See how here, I don't like this. I need to have a dummy variable right here and right here, right here and right here, because if I were to do t of t, that doesn't work. So I'm gonna go ahead and change that so that it is a dummy variable right here. All right, then taking the derivative of that, I'm going to get s of t and then b of t right here. And I'm going to figure out when that is a maximum. So I'm going to set this equal to 0. Notice how I'm doing it one line at a time, setting that equal to 0. Now that's already ny3, so that's great. I'm going to go ahead and uncheck and clear y1 and y2 because I don't need her. I do want y3, so that's great. Now my window should be from 0 to 5. So 0 to 5. And then my ymin, ymax should probably be from -1 to 1 because I want to find my critical point. I'm going to graph it, and you can see that I have a critical point at that x value. So we're going to go ahead and trace and figure out that. This handy calculator already gave me the 0, but your 84 would not. So you're just going to have to do second calc and call it a day to find your 0. But doing that, you can see that I have a critical point at 4.37323. If you don't do anything with the calculator, it's going to store x to be 4.37323. So just keep it like that for now. But I do know that my critical point is going to be 4.37323. Once you do that, you're going to make your little table. I want an absolute maximum, so I'm going to include my endpoints of 0, 4.37323, 5. Well, at 0, we're just starting at 0, so that's just going to be 500. And then I want to figure out what 4.37323 is and 5 based off of my integral right here. So I'm going to do 500 plus the integral from 2 to x. And remember that x was stored as 4.3723. And then this is going to be my rate to n. In this case, my rate to n was my y2 function. So that's going to be my first part. Then I have my rate out, so I'm going to do minus the integral from 0 to x. So the amount that the coal is burning of y1 dx. And then if I hit enter, that's going to give me 513.505. 513.505. Now yours might be a little bit different depending on how you rounded your time t value. So it should be around 513-ish. What I'm going to do now is also do 5 instead of x. So find out the total amount of coal at time t is equal to 5. And that's going to be 512.803. The question is asking us at what time will the coal be a maximum. So that time was going to be 4.37323 with 513.505 pounds of coal. All right, part D. After time t is equal to 5 hours, the coal continues to burn until there are 0 pounds of coal remaining. Write an equation involving one or more integral expressions that gives the time t is equal to k where the coal is all exhausted. There are a couple of ways that you could do this. So I'm just going to show you those ways here. The first way is you already defining what A of t is. So if I already know what A of t is, then I could say what A of 5 is. which is 512.803. So we have A of 5, and then we have my rate out from 5 to K of B of T dt is equal to 0. It tells you to write an equation, so you do need the equal to 0. Some of you guys just gave me the expression, and that would not give you full credit there. Now, some of you guys also just looked at, let's say, A of t and did 500 plus the rate n parts from 2 to 5 of s of t dt. And then you also gave me the rate out part from 0 to k b of t dt. So that would also give you the correct answer, because I had my initial value 500. I'm adding coal from hour 2 to hour 5, and then I'm subtracting coal from 0 to some k value. So that would have been another correct answer there. And then some of you guys, nope, I think that's it. Yeah. Some of you guys did this right here. The problem with this is, once again, I'm not adding coal at time t is equal to 0 or time t is equal to 1. So I can't do this right here, because once again, this is telling me that I'm starting at time t is equal to 0 for me putting coal in the furnace. All right, once again, please make sure that you read the problem fully before attempting the problem, because once again, your rate out time might be different from your rate in time. So if you did from 0 to 5 here, that was wrong. If you did 0 to t here and 0 to t here, that was also wrong. So we didn't earn a lot of points here, but that's going to be a good lesson for this FRQ, is to read the problem and make sure that your time interval is correct.